Good afternoon, students. Today we are going to solve the applications of plane mechanism and inversion of mechanism, and what is the Kutzbach criteria and Grubler criteria. In the last class, we have studied about the number of joints, that is ternary, binary, and quaternary, and how we are defining the kinematic chain as completely constrained chain or locked chain, that is structural chain or unconstrained chain, based on the formula J equal to 3 by 2 L minus 2, which was developed by A.W. Klein. Is the scientist found the equation for the joints and the number of links, or the relation between the binary joints and the number of links. In the continue of that, we studied also what is a mechanism. Then what is a mechanism? When one of the four links, we are having that in the one of the links is fixed. So when one of the links in a kinematic chain is fixed, then the chain is known as a mechanism. And when this mechanism is coming to the some useful work, then we will call it as a machine. Then how the mechanism will form means minimum four links are to be required to form the simple mechanism. And also the number of degrees of freedom for plane mechanism is found from the relation n is equals to 3 into L minus 1 minus 2j minus h, that is the number of higher plates. So we are now coming to the applications of those equations, that is n equal to 3 into L minus 1 minus 2j. So in this condition, the Kutzbach criteria. So the application of the Kutzbach criteria, this equation we will call it as a Kutzbach equation, and this equation is to be implemented in the number of mechanisms. So here the mechanism is there. So if you see the diagram A, that is 3-bar mechanism. In this 3-bar mechanism, we are deriving the n value, that is n is equals to 3 into L minus 1 minus 2j. What is the number of degrees of freedom or movability? N is equals to 3 into how many number of links? 3 minus 1 minus 2 into binary joints. Here J means not the joints, it is purely binary joints. Binary joints means when two links are connected to same joint. So here the number of binary joints has 3. So into 3. 3 into 2 minus 3 into 2, that is 3 into 6 minus 6, that is equals to 0. So for figure A, n is equals to 0. Then coming to the second one. So what is the meaning of the number of degrees of freedom, that is n is equals to so and so value, which defines the number of degrees of freedom, that we will discuss in the end of this problem to solve. So coming to next one. What is the next one? n is equals to 3 into number of degrees 1, 2, 3, 4. 4 links minus 1 minus 2. Binary joints are 4 only. So 3 into 3 minus 4 into 8. It is equals to 9 minus 1. It is equals to 1. So for this case, n is equals to 1. So these things we will discuss in the end of this session. Then, the same way, we go for the another one. It is for problem C. N is equals to 3 into number of links is 5 minus 1 minus 2 number of joints, binary joints as so 3 into 4, 5 into 2, 10. So 12 minus 10 it is. So for this case, n is equals to then what about the d? N is equals to 3 into how many number of links? 1, 2, 3, 4, 5. 5 minus 1 minus 2 number of binary joints. Here binary joints are B and D. So that is 2 plus B and D is over. One is A and C. A is having 3 joints and C is also having 3 joints. So 2 ternary, 1 ternary is equals to 2 binary. So 3 into 4 minus 2 into 2 plus 4. This is called the one set. 12 minus 2 into this is 6. So 12 minus 12 it is equals to 3. Here also n is equals to. Then what about the last one? N is equals to 3 into number of links. How many links? 1, 2, 3, 4, 5, 6. 6 minus 1 minus 2. Number of joints. Binary joints as A is having 1, 2, 3. B is having 1, 2, 3. C is having 1, 2, 3. D is also having 1, 2, 3. So 4 ternary 4 into so 3 into 5 minus 2 into 15 minus 16. So minus here n is equals to. So now among all these we are concluding here. So we achieved n is equals to 2, n is equals to 0, n is equals to minus 1. So simply n is 0, 1, 2, minus 1. So what is the case? So when n is equals to 0, so from the diagram, when n is equals to 0, in what are the problems we are having? In the problem A and D and B. See here 0, D and A. D and A, the figure in the figure A and D, we are getting the number of degrees of freedom as 0. That means no degrees of freedom, no degrees of freedom. So it is called as a structure or rigid one. No relative motion between them. So one link to another link there was no relative motion. When no motion is there, it is called as a rigid one or structure. When n is equals to 1, this mechanism is occurred at where? In the B, figure B. So this mechanism can be derived by a single input motion. And next, n is equals to 2 means two separate input motions are necessary to produce constrained motion. That is occurred in the figure D. So in the figure C, we are getting the same. And whatever the last E1, when n is equals to -1 or less, there are redundant constraints in the chain. It forms statistically indeterminate structure. So it is not a structure. Beyond the structure, it is indeterminate. That means we can't able to frame the structure also. So n is equals to 0 means it is a structure. N is equals to 1 means one single degree of freedom. One input motion is enough to move the mechanism, and 2 means two separate input motions are necessary to produce the constrained motion of a mechanism. And n is equals to -1 or less than 0 is nothing but it is redundant constraint. So next we will solve the same problem or same equation for these some different models. If you see here, this is also the like that of same thing, but I link 1 and 2 and 3. So here it is of a structure like this, or the mechanism will be like this. Mechanism is one thing was one link was fixed, but here you just to need to concentrate on that means these thing and this, that means second and third is framing a point, or they are in contact either by a line or a point. They are in closely contacting, look like a point or a line. So the point or a line means here the higher pairs will come into the picture. Then the formula will becomes n is equals to 3 into l minus 1 minus 2j 2g minus h. This is the basic formula that was Kutzbach. So substitute for that, n is equals to 3 into number of links as 3 minus 1, number of joints it has 2, minus higher pair is only 1. So for that, 3 into 2, 6 minus 4 minus 1. So 6 minus 4, that is equals to 1. So in this case, 1 degree of freedom. So coming to the next one. In this case, we are having 4 links. One is fixed, 2 is rotating here, and third and the fourth. The fourth link is connected to the first link. This is a contact called point or a line contact. So here the wheel is touching the link 1. So the fourth is connected to the first one by a point contact. So in this case, what is the relation? N is equals to 3 into 4 minus 1, that is 3 minus 2. Number of joints, how many of number of joints here? 3, 1, 2, 3. 1, 2, so 3 minus number of higher pairs as 9 minus 5 minus 9 minus 6 minus 1. 9 minus 7. That is 2 higher pairs where n is equals to 2 and here n is equals to 1. So with that, the Kutzbach criteria which was applied to the mechanisms for a higher weights. Then coming to Grubler's criteria for plane mechanism. This mechanism is applies with only single degree of freedom joints are there. So only single degree of freedom are there means this equation will be supplied. So single degree of freedom means then Grubler's criteria is only applicable for single degree of freedom. That means n is equals to 1 and 3l minus 1 minus 2j. And at the same time, no higher pairs is also there. So this becomes 1 is equals to 3l minus 3 minus 2j. That is 2 3l minus 2j equal to 4, or 3l minus 2j minus 4 is equals to 0. This formula we will call it as a Grubler's criteria or Grubler's equation. So from where we are getting this equation? That is Kutzbach equation. When the Kutzbach equation is having a single degree of freedom only having single degree of freedom, this will becomes Grubler's criteria. This Grubler criteria for mechanism for plane mechanism is with the constrained motion, and we are having a 4-bar mechanism and a slider cranknet in which the number of links is equals to 4 and the number of joints is 4. So for what mechanism we can frame this Grubler's mechanism means only a single slider crank mechanism will forms this Grubler's criteria. And next, the inversion of mechanism. Inversion means, see here, what is mechanism? Mechanism means when one of the link is fixed in a kinematic chain. So this is a chain which are all having A, B, C, D and E, and this is link 1, link 2, link 3, 4. If one link is fixed, that is called it as a mechanism. So here we fix A, B link or first link is fixed. This is a mechanism. It is a simple mechanism. So when we change, so if you change this fixing of, when we change the fixing of AB link, when we change the fixing of AB link to AE link, only we are fixing this link only. So if it was there, so here the fixed link is changed from AB to what? AE. So this is called an inversion of mechanism. So actually basic mechanism is by fixing of AB was achieved, but we are changing the fixed links to other than AB, then it is called the inversion of mechanism. So the inversion of mechanism means from the original we are rushing to from the original. So if you fix AB, if you fix the link 1, we achieved a mechanism. If you fix to second link, we will get a one more mechanism which was different from the original one. This is called, by let us consider, this is the default mechanism. If you change the fixed link from 1 to 2, it will form a one more mechanism which is different from the default mechanism. So this is a extra mechanism, and at the same time, then if you fix only 3, so if you fix 3, we will get, or we will receive a some other mechanism, and 4 and 5. So in this case, if you see here, for these mechanism, the inversion of mechanisms are 4. That means from the default mechanism, we are achieving 4 different mechanisms by fixing of the number of links in a kinematic chain. So we will get it the 4 different mechanisms. So that is called a inversion of mechanism. Inversion means the conversion of the mechanism into, or the modification of the original mechanism. We will call it as a inversion of mechanism. So this method of obtaining the different mechanisms by fixing the different links in a kinematic chain, which is known as inversion of mechanism. Here also the same thing. So here also the link 1, and this is 2, this is 3. By simply fixing of first link, we are receiving the a mechanism, that is original mechanism. By changing these fixing of link 1, instead of 1, we change it to third link. That means this link was freely, that means if it was not fixed, we are getting one more mechanism, and at the same time 2. That means here we are getting 2 different mechanisms. So this is called the inversion of mechanism. Then kinematic chains types. So here it may be noted that the relative motion between the various links is not be changed. The motion of various links may not be changed in any manner throughout the process of inversion, but their absolute motion may be changed by changing the trafficability. So by changing this here, their motion may not be changed, but their absolute motion will be changed. So this is a very important thing, we need to note it. Next, types of kinematic chains. The most important kinematic chains are those which consist of 4 lower pairs. So lower pairs mean they are only having surface contact only. Each pair being a sliding pair or a turning pair. So here in the kinematic chain, which are having 4 lower pairs, which consists of 4 lower pairs. Each pair may be having sliding pair or a turning pair. Then this we will call it as a, based on that we are segregating these 2 different kinematic chains. So here with 4 lower pairs are different from the subject point of view. One is 4-bar chain or quadratic cycle chain, and single slider crank chain and double slider crank chain. Firstly, we go through the 4-bar chain or quadratic chain. We know that The kinematic chain is a combination of 4 or more kinematic pairs such that the relative motion between them is completely a constant. You know that whether it is a chain, kinematic chain means it is to follow some rules and regulations. That is, J is equal to 3L 3 by 2 into L minus 1. That is the formula we need to satisfy. So for every kinematic chain, if it was a kinematic chain, it is to be of kinematic pairs. Relative motion is always be completely constant. This is the simplest and basic kinematic chain in a 4-bar mechanism is a quadratic cycle chain. It consists of the 4 links. It consists of the 4 links. Each of them will form a turning pair at, see here, at A, B, C, D. So if you see the 4-bar kinematic chain, at every point of A, B, C, D, they will form the turning pair. So either maybe a turning pair or a sliding pair it has to follow. So here in a 4-bar chain, it may follow, what is the thing? Turning pairs at A, B, C. But the links of the 4-bar chain will be of different lengths among all the things. So which is not be equal AB with the remaining 3 links. The first link may not be equal to any of the rest of the 3 things. At the same time, the fourth link is not be equal to the rest of the 3 things. That is 3, 2, 1 also. So according to Groshoff's law, for a 4-bar mechanism, the number of links what we are having and the sum of the shortest and the longest lengths should not be greater than the sum of the remaining 2 links. So what is the shortest and the longest we are having here? So shortest and the longest we are having. Shortest is the 4th link and the longest is the 3rd link, which may not be greater than remaining 2 links, that is 1 and 2. So this is only for the symbolically we can say that the length of shortest and the longest may not be greater than the length of the remaining 2 links. And an important consideration in designing a mechanism is to ensure that the input cranks may be a complete revolution relative to the other links. See here in this, what are the cranks and what are the remaining elements that we need to follow up that. In a 4-bar chain, one of the links in a particularly short link, say here, particularly in a short link, that is link 4, that is link 4 will make the complete revolution relative to the remaining 3. So it is known it as a crank. So among the 4 links, which one is rotating 360 degrees, that is completely revolution, than the other links, that is known as a crank or a driver, that we need to remember. So here the crank is nothing but the link AD or 4th link is the crank. Then coming to the link BC, 2nd link, which makes the partial rotation. So BC is partial rotation or oscillation, that is called as a follower. Link 2 we call it as a follower or lever. Crank, this is the crank, the link 4 is the crank and link 2 is the lever, and link CD which connects the crank and the lever. So what we will call it as crank to lever connection. We will call it as a coupler or connecting rod. Connecting rod or coupler. So fourth link is rotating complete revolution, so it is called as a crank. Then we see second link, it is a partial rotation, so call it as a lever. And the connection between crank and the lever, call it as a connecting rod. And what about the rest of the thing? The link 1 is a fixed frame. So fixed frame of the mechanism. So among the four, any one of the thing is to be fixed. So here one is called the fixed link 1. Link 1 is fixed frame. So what is our operation? Here the link 4 is the driver or a crank that will mechanism the turning or rotary motion, that is to what is the movement of the link 2 to the oscillatory motion. So rotary to oscillatory motion, and this motion is connected through a connecting rod of a 4-bar mechanism. So this is the final thing we need to remember. So in any 4-bar mechanism which follows the kinematic chain and it satisfies the constraint motion. So briefly what we can say in the today's class as the Kutzbach equation, what we are knowing this as n is equals to 3 into L minus 1 minus 2j minus h is to be transferred to Grubler's criteria, but this Grubler's criteria is only for single degree of freedom where n is equals to 1 and there was no higher base. So the equation of n is equals to 3 into L minus 1 minus 2j minus h will be transformed to 3L minus 2j minus 4 equal to 0. This equation we will call it as a Grubler's criteria for plane mechanism. And what is the inversion of mechanism? Inversion of mechanism is nothing but when one of the links is fixed in a kinematic chain is called a mechanism, and the number of links in a kinematic chain by fixing in turn with different links in a kinematic chain. That means among these links we have to alter the fixing of the links. By altering the fixing of the links, we get it a different mechanisms. So these mechanisms are found from the inversion of original mechanism. So that is called the inversion of mechanism. And the types of kinematic chain are which are having the lower pairs. The kinematic chains which are having the lower pairs, and these lower pairs being a sliding pair or a turning pair. Based on these conditions, we are segregated to three types. One is 4-bar chain or quadratic cycle chain, and single slider crank chain and double slider crank chain. So in the today's class, we extended up to 4-bar chain or quadratic cycle chain mechanism, how it will works. And Grosshoff's law. Grosshoff's law was found that the shorter and the longest links, the sum of the shorter and the longest link's length should not be greater than the remaining two links. So in a 4-bar mechanism, we need to satisfy that, and then simply in a video, the operation or the animation of this 4-bar chain mechanism and working of the 4-bar chain mechanism will be shown. Just a minute. See here, this is rotating about 360 degrees. So this we are call it as a crank. The blue color will indicate the crank since it is rotating 360 degrees or complete revolution. And what about the red color? This red color is just partially rotating. So partially rotating. So these partially rotating or oscillating. That is called as a lever. The blue color indicates the crank and the red color indicates the lever. And these red and blue are connected to this. Red and blue are connected by a connecting rod that is in the yellow color, and at the same time no changes in the motion, that is the gray color is no changes, that is it is a fixed link. So here the crank is rotating 360 degrees and making the lever a oscillatory motion through a connecting rod. This is the 4-bar chain or quadratic cycle chain.